My name is Ram Sagar. I am working at Indian Institute of Astrophysics as a retired scientist, NASI Senior Scientist Platinum Jubilee Fellow. In this talk, I am going to tell you about star clusters in their basic definition, properties in our galaxy, and how these properties change if you study star cluster in external galaxies. And towards the end also I will tell you how to separate field star from cluster members, because in the sky a star cluster is located, let us say, 1000 light year away. Then if it is in our galaxy, we have foreground stars and background stars. So, while we take images, they all are projected, but cluster members are almost located at the same distance, others are not. So, how to separate them and what are the properties of that I am going to tell you. I am happy to talk on this topic. In fact, this topic is very close to my heart. It was part of my PhD thesis about 45 years ago. So, in this slide, by definition, they are group of gravitationally bound stars and presumably created from the same material. Actually, it is true, since they are formed from the same giant molecular cloud. So, it is expected that their chemical composition and other properties, they are similar in all the stars. Since they are located in the gravitational potential of a galaxy in which they are formed, that is why they move together through the star field in a galaxy, and then they encounter various type of gravitational interaction with galaxy and also stellar evolution and all those things, what we call dynamical evolution, and a combination of these things determine the lifetime of star clusters. In fact, that is what we call dynamical lifetime of star clusters, and typically depending upon how tightly bound system is, lifetime differs. For example, in loose clusters, it is just few hundred mega years, while in very tightly bound clusters, it is of the order of several giga years. Because they are formed from the same molecular cloud, they are located, all member stars, they are located at the same distance, because the distance from us where they are located, that is very large compared to the depth of the or compared to radius of the cluster in most of the cases. That is why practically for all purposes we can say that they are located at the same distance. And during star formation process, although it takes few mega years, but if we talk about some compact objects which are known as globular clusters, whose ages are more than 10 giga year, then few years ago or a decade ago, it was believed that all of them, they were formed in one epoch, but recently Hubble Space Telescope observation and precise photometry of that has clearly shown that this coeval formation of all the stars in a cluster may not be justified. In fact, it reveals there are several epochs of star formation. So, this is a new information about star formation processes in star clusters. Since all the members they are located at the same distance, as a result their color magnitude diagram, in other words brightness versus temperature diagram, it becomes equivalent to HR diagram. And in fact, this property is very useful for study of stellar evolution, and it is due to this reason star clusters are known to be very excellent tool to test stellar evolutionary theory. Contrary to that, if we try to study a single star, then it is not easy, because in case of single star we have to find out distance and other property, so that we can put it in the color magnitude diagram. But in case of star clusters, because they are located at the same distance and they have range of masses, their color magnitude diagram represents like a HR diagram in astrophysics. Next slide, it displays two pictures of star clusters which are in our Milky Way. In fact, one they are taken from SDSS sky survey, and as you can see one group of cluster, they are so compactly bound that at the center of the image we are unable to resolve them, and only integrated light observation of this part is available, and they are called globular cluster, and its catalog number is M13. And studies have shown that its age is about 12 giga-year. It is located in our galaxy at a distance of about 10 kpc, and stars which are member of these clusters, they have mass less than 1 solar mass, but the number is so large, in fact several millions, that if we talk about the total mass of the cluster, then it is of the order of 10 to the power 6 solar mass. And you know what is the value of 1 solar mass. So, these are very massive stellar system, they are floating around in our galaxy, and because of this spherical shape and compactness, they are called globular clusters. And since they are low mass star, if you see their integrated light, it looks blue, it looks red, it is not blue, because most of the stars are late type of stars. Other side, if you see this picture, this is what we called open cluster, or it is also called as a galactic cluster. In fact, its catalog number is Messiah 16. It is also popularly known as Eagle Nebula. In this cluster, if you see, contrary to globular clusters, all stars are well resolved, and it is quite young, because its age is roughly about 10 mega year. Distance is nearby compared to this globular cluster, it is about 2 kpc, and it has wide mass range compared to the mass range of globular cluster. In this case, lowest mass is something about 0.1 solar mass, means it has some pre-main sequence stars, and massive stars they have already reached on the main sequence, 0 age main sequence, and they are of the order of 40 solar mass. But if we take total mass of this system, it is much smaller than the globular cluster mass. It is of the order of 10 to the power 3 solar mass, and all the members, all the stars are well resolved in this picture. I am just comparing what are the other properties of Milky Way galactic and globular cluster. So, I have made 3 columns. In one column, I am just putting the items like what are the number of member stars in a cluster. If we talk about open clusters, then the minimum number can be even few tens things up to few hundreds. But if we talk about globular clusters, then the number of members are several thousands. If we talk about mass range, what is the range of mass of the member stars? In case of galactic open cluster, they are 0.12. If it is a very young object, depending upon the model, it could be of the order of 100. In fact, in some cases, even main sequence stars of 130, 140 solar masses have been observed, and they are very young, and subsolar mass stars, they are still in the pre-main sequence phase. In case of globular cluster, all the members are less than 1 solar mass. This is simply because of the fact that due to large age of the globular clusters, massive stars have already evolved from the main sequence, and they have reached to the red giant, horizontal branch, and late stages of stellar evolution. And in fact, this is also reflected from this row, which where I have indicated age of the system in years. So, in case of galactic open clusters, they are in fact young and mega years to few giga years. There are in fact, if we see globular clusters, then most of them they have ages more than 10 giga year. In fact, globular clusters are the oldest object in our galaxy, and if you see star formation processes in the galaxy have taken place in such a way that there seems to be some gap, because star clusters which are loose, they have maximum age only few giga year. On the other hand, globular cluster formation must have taken somewhat earlier, because their age is more than 10 giga year. If we take the shape, then these are loose and irregular in shape, while globular clusters are spherical in shape, very compact and strongly bound gravitationally. If we talk about integrated magnitude, suppose if we are not able to resolve a star individually, and if we observe, then the magnitude range in case of galactic open cluster, it is a wide range, more than 10 magnitude. Contrary to that, in case of globular cluster, it is a narrow range, only few magnitude. If we talk about total mass of the system, then open clusters are generally less than 10 to the power 3 solar mass, and globular clusters are more than 10 to the power 6 solar mass. So, it looks like there is a dichotomy in the masses, total mass of these clusters, that one is in the lower range less than 10 to the power 3 solar mass, other is in the higher range 10 to the power 6 solar mass. If we talk about the metallicity, so in fact, globular clusters are being oldest, they are called population 2 or object, and they have wide range in metallicity. And galactic open clusters, they are younger and looks like they are formed from the molecular cloud, where already some nuclear debris and other things they have mixed. So, the metallicity of these galactic globular cluster is like sun or solar metallicity. If we talk about location of these objects in the galaxy, then galactic open clusters, they are basically lying along the disk of the galaxy. In fact, their precise determination help us to study the structure of the disk and structure of our galaxy also. If we study the distribution of globular clusters in the galaxy, they are spread over all over part of the disk. They are in the disk, they are in the halo, and they are in different part of the things. So, these differentiation what I have just discussed and mentioned, which is valid for our galaxy, these differences disappears if we see a star cluster located in external galaxies. For example, in Magellanic Cloud, there is no distinction between open and globular cluster like in the Milky Way, and this can be understood from this slide, which is showing the location of star clusters in the large Magellanic Cloud, and this is also a picture from SDSS Sky Survey. You can see there are fuzzy objects, and all these things are in fact star clusters. And a high resolution picture of this taken with HST clearly shows that they are young, but integrated light blue. So, in the shape wise they looks like our old globular cluster, but age wise they are like galactic open cluster. So, that is why they are called young blue globular clusters, and the meaning of galactic and globular cluster in our galaxy, it loses its meaning, and henceforth I will say star cluster in a galaxy other than Milky Way, classifications are not exactly identical, they are different. In this case, these clusters which I am young cluster I am saying, they are about 100 mega year, distance of the LMC is about 55 kpc, and the mass range is again 0.1 to 40 solar mass. In this case, total mass of the system is much larger than what it was for young clusters in our galaxy. In this case, it is of the order of 10 to the power 5 solar mass. So, if we try to summarize that star cluster in a galaxy, what are their properties, then they cover huge range in total mass, depending upon how compact, how small they are. It could be from 10 to the power 2 to 10 power 6 solar mass. Ages, it could be few mega years, youngest objects, to the oldest, which could be are believed to be as old as our universe. So, more than 10 giga year, and it is because of these reason, in fact, age of the clusters, globular clusters, used to constrain age of the universe also. And structure wise, some are very compact, that is why they are called globular, they are rich, while others are very loose, and because of loose structure they are sparse, gravitationally not tightly bound, and hence extended. I can summarize that star clusters are valuable for understanding of star formation processes and study of stellar evolution and galactic structure in a galaxy, because whatever I described earlier, that properties help us to study star clusters young, which can tell us what was the star formation process, because young star clusters can be used to find out initial mass function, star formation efficiency, and various things. Hence, they are very valuable, and their color magnitude diagram can be used to study the stellar evolution in different galaxies, and once we find their distances, then they can be used to study the galactic structure. However, observationally there are some constants. Briefly, I will just mention them here. As we saw in previous slide, in case of globular cluster M13, at the center any ground based telescope is unable to resolve, and in that case we only observe their integrated light observation. But modern techniques and modern detectors and also both ground and space based multi-wavelength observational facilities, they have been able to resolve stellar population. In fact, there is a saying which is very true, that in general ground based resolution without use of adaptive optics is of the order of about 1 arc second, while the for Hubble Space Telescope, 2.3 meter Hubble Space Telescope, it is of the order of 0.1 arc second. Consequently, those regions of the star clusters like center of the galactic globular clusters, which are not resolved by ground based facility, they are resolved by these new techniques. Next two slide, I will try to demonstrate how these observational techniques have helped us to understand them. Title of this slide is a revolution in ground based direct imaging, and what is shown in the four corner of this picture, it is a Omega Centauri, a small portion of this which is 12 arc second by 12 arc second. As you know, Omega Centauri is a well known globular cluster in southern hemisphere. So, the first image A, which is written here, it was taken with CIMMYT telescope, where seeing, or in other words you can say resolution was very poor. It was of the order of 2 arc second and 10-minute exposure time, and you can see other details which are written here. Then we see some blobs, some may say image defects and this and that. In fact, till we had better resolving power facilities, that is till these things were resolved, it was difficult to find out how many stars are there. But if you see the picture B, which is taken with better seeing, it is 1 arc second and 3.6 meter telescope. Because of better seeing, this one blob, it splits in number of stars, and the similar thing as you can see. So, we are able to detect faint objects in less exposure time, and here plate scale was 7.2 arc second per millimeter. So, here we have angular resolution better, wavelength range is also different. You might have heard name of new technology telescope, where it was installed in late 80s, and it has capability of adjusting or improving its seeing parameter very frequently. Consequently, if you see those blob which was here you see 4 stars, but it is again further resolved. So, resolving power has improved drastically, and in a short less than exposure time of A and B, we are able to detect fainter objects, and in this case seeing was 0.3 arc second. So, you can see, and full width of half maxima image in this case is 0.33 arc second. So, you can see as soon as the resolving power improve, we see resolved portion which were not otherwise we were able to study, and this says what is the power of image processing. This image which is displayed in C, when techniques of image processing were used, images were sharpened by advanced techniques of image processing, and full width half maxima it reduces from 0.35 to 0.18 arc second. So, that is why it shows that how resolution helps. In other picture, core of the galactic globular cluster MESA 15, this is ground based image. When it was imaged with HST wide field camera, then you can see all the stars are resolved, and in fact, you see some blue objects and they are the white dwarfs. And as I mentioned earlier, this has become possible because of the fact that angular resolution of the Hubble Space Telescope is roughly 10 times better than the ground based telescope, which are not using adaptive optics. So, in a sense, Hubble Space Telescope, these type of images, they provide first time stellar population of the core of galactic globular clusters. So, these two slides, they showed power of better resolution, how it helps in understanding individual stars and stellar population, and how Hubble Space Telescopes have featured and improved our understanding. In fact, this slide I will say it is very important, because as I mentioned earlier, a star cluster is located in a galaxy at a certain distance. Let us say it is about 3 kiloparsec. Then we have stars which are lying in front of them, which we call as a foreground stars, and also there are stars which are lying behind it, which we call as a field stars. So, if we see the region as I displayed earlier, then we see it is a superimposition, because all the stars which are in the line of sight of the star clusters, they are imaged. So, we have cluster members, but there are also which are background and foreground stars, which we are calling them as a field stars, because they are not member of the cluster. Before we derive any property of the star cluster, separation of field stars from cluster member is essential, because if we have to study property of the cluster, then this separation is essential. For this, what is the method? There are various methods which are used in this process. One is called statistical. This method, it assumes that around the cluster region, distribution of field stars is uniform. So, for this purpose, we image cluster region, and we also image a region which is about few core radius away from the cluster, and then we find out through a statistical technique how many field stars are there, and we remove them statistically. That is why this method is called statistical method. The next method is called photometric. If suppose we are not able to observe all these things, and in fact, photometric methods, they were used till quite frequently before advent of two dimensional very good quality CCD imaging capability. And in that case, the basic assumption goes that since all the star of a cluster, all the member of a cluster, they were formed roughly at the same time, they are located at the same distance. So, the major difference between them is mass. So, if we look into the HR diagram, they will form a well defined sequence, and that technique is called photometric. But the major limitation is that in that process, if there are some peculiar cluster members, we will be calling them as a field star, because we assume that all stars form process which we well understood. But there are processes which are not well understood, and in that case there are some stars which were one of them I will call blue straggler stars in globular clusters. they were earlier using photometric technique, they were called as a field stars, but later on kinematics, which is the most reliable technique for the separation of field stars from cluster member. Why it is reliable? Because since all the cluster members are located at the same distance in a galaxy, so in the potential of galaxy their motion will be similar, and in fact that is the most reliable technique used for separating cluster member from field stars. And while I am saying space motion, it can be split into two parts. One is radial velocity, the component of the motion which is towards us, other is perpendicular to the our direction, which is called proper motion. So, in fact, these two parameters, using modern techniques, they have become available and they are playing a major role in our understanding of star formation and stellar evolution. In fact, I will summarize saying that HST and high resolution CCD imaging observational techniques, they have thrown a lot of light towards this proper motion measurement. So, whatever proper motion measurements we were doing, let us say few decades ago, for that we were taking images using photographic techniques and CIMMYT telescope. So, the epoch difference, time difference needed generally for a cluster located at 1 kiloparsec of 20 to 30 years. That time difference has reduced because of these techniques and high resolution imaging to just few years. In fact, in this direction, recent European space mission like Hipparchus and Gaia, they have provided significant information, and in fact, they have provided very accurate measurements of proper motion and radial velocity, as well as multicolor photometric and spectral information with unprecedented accuracy. And in fact, these further details we can see in these two references, which is shown as in red color, and they are very important. Due to shortage of time, I am not expanding on those aspects. How it affects and how it improves, this figure is taken from Anderson et al. It is a published paper in Astronomy Astrophysics, and you can see how high precision CCD astrometry of a star cluster improves our thing. This is a reason. This in fact, as you can see, the upper box shows proper motion, we call it as a vector point diagram. The lower part shows color magnitude diagram of the stars. So, if you see, first let us see color magnitude diagram of this portion. We see some well defined sequence, then it is blurred with so many stars, and we do not know which one is field star, which one is cluster member. Of course, we expect that the well defined sequence should be the member of cluster. But if you see their proper motion, they are clearly different. In the vector point diagram, cluster members motion, they are centered at one place depending upon the error of the observation, and that circle is shown here. Field stars, they have different value of motion, and that is shown as open circle. You see what happened to the color magnitude diagram if we separate them. Display diagram, it shows that if these stars are plotted, we see well defined cluster sequence. We have well developed red giant branch, main sequence turn off point, and in fact, some stars which are lying here, they are kinematically member, and in fact, they are called blue straggler stars. This is horizontal branch, and in some cluster we also see location of white dwarf. And if you see field star, which is separated with based on their astrometric motion, that is proper motion, they have mixture because they are located at different distances. They are in the foreground of the cluster as well as in the background. That is why their color magnitude diagram is quite different, and they do not have a well defined star cluster sequence. They have different type of structure, and that is why this in fact shows that how high precision CCD imaging devices have helped us to find out accurate measurement of proper motion and this. And in fact, Gaia and Hipparchus, they have improved our measurement accuracy of this further, and they have provided sample of measurements which are very useful for separating cluster member and field stars based on this kinematic motion, which is the most reliable criteria for separating cluster member from field stars. Thank you.